Applause for Ignat. Woo!
Hi everyone, my name is Ignat. I work for Cloudflare, and today we're going to talk about passwords. Let me just take a moment. I haven't presented on a stage for 18 months. I'll just feel the. It feels nice to be back. Yeah. First, a little bit about myself. I do Linux at Cloudflare, and I'm also passionate about security and crypto. And I enjoy low-level programming. I like to do Linux kernel, different bootloaders, and other very scary low-level C stuff. But today we're going to talk about passwords. And a bit of an advance warning, this presentation is Star Wars themed, so please, a little bit of Star Wars as well. Yeah, but passwords have a very long history, and actually, like, we can trace them back to early Roman Empire, so passwords were even used back then. So Roman military used passwords to authenticate each other when they changed shifts. And they even had a very sophisticated password rotation scheme. So passwords were, or they called them watchwords, were rotated daily. So it was quite impressive back then. And even today, passwords are still the most widely used pillar of authentication. So who here thinks passwords are obsolete? So we talk about all these new methods like two-factor authentications, hardware security keys, but in the end, it just shifts the password authentication elsewhere. For example, if you have a security key, usually you need to authenticate yourself to it with a password. So passwords will stay with us for some time as well. Yeah, and because like passwords are used to protect so many interesting things like personal data, access to different web services, and other stuff, they are frequently a target of an attack. So what are let's review the most common password attacks. They can probably broken down to three like major categories. The first type of the first simple password attack type is just a simple brute force attack. And yeah, sorry, I just got confused a bit. Yeah, so three types of password attacks. We can say brute force attack. We have dictionary attacks, and we have different services, account hijacks, and leaks. So what about the brute force attack? Brute force attack is the most simple type of a password attack where an attacker tries to actually try every possible combination of every password, and before they succeed and actually get access to the service. It's very time consuming and resource intensive. So the longer your password is, the harder it is to mount. Dictionary attacks is probably not what you see on this slide. So in this case, the attacker tries to exploit the human nature that humans do not come up with passwords as random character strings, but they usually use real words. And so they compile, and like many humans use the same words for passwords. So they compile a big list of words commonly used as a password. Then they usually develop some kind of automation to actually, because those lists are quite huge, like thousands and millions of passwords, and they just try each password from the list until they succeed to get into the service. And the third potential type is service account hijack and leaks, which can be further broken down to client-side attacks, where for things like phishing emails, insecure or fake login pages, and some kind of social engineering. So they're client-side because the attackers try to somehow steal the password from the user or the client itself. And we have the server-side attacks where sometimes the account databases with password leak. We have code vulnerabilities. The previous talk showed us a lot like how threat actors use code vulnerabilities to get into the systems. And the same social engineering. So sometimes the attackers try to social engineer the specific service customer support team to give away users' information. So based on these attacks, modern passwords to be secure have to comply with some specific requirements. So first of all, they have to be long to actually be protected from brute force attacks. They have to be random-like to actually be protected from dictionary attacks. They have to be hard to guess to be protected from both and other types of attacks. So don't use your birthday as a password, for example. And most importantly, never to be used for N websites, because the attackers usually take the path of least resistance. If they somehow hijack your password in one of your websites, they will definitely try the same password on all the other services you use. So the weakest website will compromise all your other services. But what it means, what all these requirements mean in terms of users, right? So long means hard to remember, right? Random-like means hard to remember. Hard to guess means hard to remember. And never used for N website means N times hard to remember, because now you have to remember a unique strong password for every service you use. And this basically becomes that as the complexity of password attacks grow, the complexity of passwords themselves grow as well, and passwords are just unsustainable these days. If you don't believe me, this is the internet standard, RFC 7616, which describes HTTP digest authentication. And it says that digest authentication should only be used with passwords that have a reasonable amount of entropy, 128-bit or more. And such passwords typically cannot be memorized by humans, but only automated web services. So even the internet standards tells us that modern secure passwords are non-memorizable. And this is HTTP digest authentication. Most web services use HTTP basic authentication, but we use both of them every day on the web. Luckily, in 21st century, we have a solution called a password manager, right? So the concept of a password manager is very simple. So you have all your different unique passwords for different services you use. You just get a database, and you store these passwords in a database. Then you come up with only one really secure password, which we'll call the master password, which is later converted to a cryptographic key, and this key is used to encrypt this database. So the advantages of a password manager are clear. So you have to remember only one password. And your other service passwords can be as complex as required, so they can be totally random string and numbers, almost and arbitrarily long in characters. And your passwords can be totally random, so you can generate random passwords for every new service you use. And it's very simple and easy to use. So hooray, we solved our problem. End of the talk. Bye. Unfortunately, no, right? So unfortunately, JavaScript strikes back, and I would say enterprise web applications, JavaScript strikes back. So who knows who this is? This is an average security product manager in an enterprise company, which says, go to their web developers and say, hey, for security reasons, you need to prevent password pasting in our password fields in our authentication forms. And this is a big problem, right? And because blocking paste prevents users from adopting password manager, which is considered the most secure way to manage your password these days, right? And a famous researcher, Troy Hunt, actually tried to understand the reasons behind this, and he went to different big companies asking why do they do that, and compiled a list of common answers they provide, and it's you can read about this in his old blog post. But to summarize, basically the most typical answer you get is clipboard security concerns. So the companies say that, oh, users might have some malware running on their laptops which can intercept passwords from the clipboard when they copy paste it. it is interesting why the same malware cannot, like, for example, steal the password, the keystrokes when the user types in the password. So it's a little bit of a security feature, I think. Some say it's for password brute force protection, but what they actually mean is they're trying to protect from dictionary attacks. So to prevent, somehow they think that hackers or threat actors try to mount a dictionary attack by manually copy pasting passwords from a list into their login form and trying thousands and millions of passwords. It's not like that. They develop some kind of automation script that probably queries some API directly. So it's still not a valid use case, in my opinion. So other responses are more vague. They say compliance requirements, although no one actually pointed out which ones. So to be honest, I haven't found any compliance security requirement in any countries which actually says directly you have to prevent password pasting. If you know such compliance requirements, please let me know. But I think it's mostly due to misinterpretation. And more vague answers because it's our procedure, it's for your security, it can't work otherwise, and some say it's just a feature of a browser. The browser just allows you to paste passwords in the password field. Well, luckily, we can fight this, right? There is a rebel movement trying to push the security community to allow password pasting on the web application. And there are some things you can do yourself. The first thing you can try is actually to restore paste functionality on such logging forms. Is if you use a Firefox web browser, you can go to its configuration and set this config to false, which will actually disable the JavaScript on copy and cut on paste events, which are usually used by web developers to block password pasting functionality. And this approach has no extra dependencies. It's easy. You just go and flip the switch. It's not very reliable because it assumes that the web developers use these events to block password paste, but there are other events, for example, which may be used by web developers. So depending on the implementation of password blocking, it may not work reliably. It's not portable, right? It's for Firefox only. If you don't use Firefox, you're in trouble. And it can break other functionality. So modern web applications are very, responsive, and they may rely on extensive JavaScript to function properly. So disabling these events is basically like cracking a nut with a sledgehammer. Or you might as well move to Link's browser as well, but it will not be very usable, right? So the second approach we could take is there are numerous of different browser extensions out there which claim to restore password pasting functionality. So the way how they work is they inject more JavaScript into your browsing data, which tries to override the paste blocking JavaScript in the web application. And they're mostly third-party extensions, and they try to actually disable the paste blocking functionality in the web application. The second type of these extensions, they just can manipulate your document object model directly and inject passwords for you in your passwords field. So these extensions are implemented by password managers themselves because they have access to your passwords, so they can just fill them for you when the web application loads in your browser. The advantages of this approach is it's also easy to install, so you just pick the extension from a web store, right? It usually requires zero or very little configuration. But there are some downsides, of course. They may be not reliable as well, again, because different web developers may use different techniques. These password paste unblocking extensions may not detect these and properly counteract and restore the password block functionality. They're not portable, so they only work for browsers, for common browsers like Firefox and Chrome, which have popular web stores, and not less popular browsers. And again, they can break other functionality, because if they're implemented incorrectly, they mess with your document object model, with your JavaScript, and like application may actually break and stop working for you. But one further downside for me specifically is security consideration. So when you install such extension, like Chrome, for example, will tell you that this extension will read and change all your data on the websites you visit. And it's actually like, there is nothing wrong with that. It's by design to actually performance functionality. It needs access to your browsing data. So basically, these extensions have access to manipulate your document object model, your browsing data, and it happens after TLS termination. So the extension sees the clear text browsing data. And because these extensions run in a browser, they have full network access, right? So let's recap here for a second. So you're installing a third-party code which has access to all your browsing data and can change it and has full networking access, right? So yeah, what could go wrong here? And these extensions, even popular ones, are not always malicious by themselves, but sometimes they're written like in JavaScript and have many JavaScript dependencies. Sometimes these dependencies get hijacked, and like these extensions can be easily weaponized by threat actors to actually start collecting your information remotely. So what can we do here, right? I had a thought about this, and because I'm an operating system developer, like, can an operating system actually help us to fix this? And I came up with a small tool called PassKB, which is an operating system paste unblocker. I think it's kind of a new hope to counteract these evil web applications which block password pasting functionality. But to understand how this works, so let's just zoom out a little bit, not dive into specific technical details, but try to understand the concept of how password paste block work in general. So you have your web application, you have your users, and your users may either try to paste the password into the login form or type it in. So password paste blocking techniques usually implement some kind of a filter, usually in JavaScript, which tries to detect paste functionality somehow, right? But what they should allow by design, they should allow typing, right? Like any web application should allow users to type in the password. And all the techniques before PassKB, what they try to do is they try to find this filter, this implementation in the web application and disable it somehow. So what if we take a different approach here? What if if the web application wants you to type in your password, let's just type it in. But instead of typing it ourselves, we will ask our operating system to do it for us. So this separate tool, you can paste the password in the separate tool, and the separate tool can emulate typing functionality into the form for you. And the web application should allow it by design because it should allow typing, right? So this is exactly how PassKB works. So yeah, again, we have the web application, we have our users, and this is like a command line utility you can run in your terminal. So if you encounter a web application which prevents password pasting, you can just paste the password into the tool, and if you run on Linux it will use the operating system dev input interface. On Windows, it will use the send input API call, which will emulate typing functionality and type your password in. So this black box is actually a pre-recorded demo, but I'll try to do it live because what's the use of the in-person conference if you do pre-recordings, right? Yeah, so I temporarily will switch my display so I can see what I'm actually doing. Okay, so here is a simple web page, right, where it emulates three fields. One field where you can actually paste your password, and there are two fields which prevent password paste blocking by using different techniques. So let's emulate a simple password manager with a secure password. So, for example, here I can paste the password here, but I cannot paste the password in these two boxes, right? So actually, here is what I can do is I can just launch my, I'll copy paste it again, just in case. I will launch my passkb tool. It asks me, okay, paste me your password. So I paste the password here, press enter, and quickly put the cursor back here and wait till it types it in. Oh. And this is one password pasting blocking technique. Here is another one, so it works with any of those. Paste and back. No hands. Yeah, so it works. Where is my display? All right. Are we back? No, just a moment. Okay, yeah, we're back. So yeah, this approach is very uniform and straightforward, except it's if you run it on Linux, it requires some additional configurations, at least. So on Linux, it uses dev input interface to emulate keystrokes. And the problem with that is like the process required read-write access to the device file, but on most Linux distributions, this file is owned by root. So you have to change that. So we have three approaches there. We can just run it as a super user, but it's not recommended because of the least privilege feature. If you're a single user of your Linux laptop, you can just change the ownership to this file to yourself, and then you can use it from your normal user. If you run a multi-user Linux distribution, it's better to create some kind of group and add all users in that group and actually allow the group to access this device file. And because on Linux, the device file system is virtual, all your changes will actually be reset on reboot. So you have to have some kind of startup script of udev-rule, which does it on every system boot. But other than that, it requires no configuration. Yeah, so the advantages of this approach is cross-platform and browser independent. So because it emulates keystrokes by the operating system, it doesn't care which browser you run, or even if you use some kind of different like fat application, which also prevents you to paste passwords. It has no access to your browsing data because it runs outside of the browser, and it actually doesn't need to have any access to your browsing data. Again, it has no network access. It's a separate tool. You can put it into container and like block it accessing anything except for the single interface it needs to emulate keystrokes. It's a separate constrained process. So even if for some reason this application is very simple, it's do one thing, Unix philosophy, but if it ever gets exploited, nobody will be able to get to your browsing data because it runs in a separate operating system process. And it's simple, reliable. There are no settings, no state, no heuristics, and no regular expressions itself. And the biggest advantage, it cannot be detected or blocked because all the paste blocking techniques need to allow typing functionality by design. They can never detect or block this type of tool. There are some downsides, as we saw from the demo. It doesn't, at least currently, work on mobile devices, but I think mobile operating systems now have their own dedicated approach to solve this problem, which is quite similar to what passkb does. And as you've seen from the demo, there are some usability inconveniences. So you have to run a terminal session alongside your browsing session, and you have like, when you paste the password into the tool, you have like 3 or 5 seconds to switch back to the browser. Otherwise, it will type your password somewhere else, wherever the cursor will be. Yeah, so it's a little bit inconvenient. So yeah, so what can you do? If you're a user and you don't use a password manager, please start using one. There are plenty of open source and commercial free ones available. If you're a web developer or that security product manager, please reconsider messing with paste functionality. Use my tool, provide feedback, and actually spread the word. With this tool available or similar tools becoming developed and more available, like the paste blocking in web application is no longer effective. If you have a separate tool which can emulate keystrokes on the operating system, you can never block such tool from the web application itself. So it's useless actually to put it there in the first place. Yeah, and I think that's it. So here are the links to the resources I used in this presentation. The first one is the link to the Troy Hunt's blog post about why companies actually block password pasting. The second one is actually a link to our government security service in the UK, which recommends, like if you ever encounter an enterprise saying, oh, we do it for security reasons, at least here in the UK, you can direct them to this resource, which actually recommends web services to actually allow users to paste their password for security reasons. The third link is the link to this test web page I used, developed by other developer, which emulates password blocking. And by the way, that developer also believes that password paste blocking is bad. They just wanted to investigate how it's done. And the final link is linked to GitHub, to my tool, which you can grab and compile yourself, or you can probably even grab a binary. Yeah, and in the end, the obligatory Star Wars meme here is like, if you block password paste, you're not a great person, and we will find you. Thank you very much for your attention. Any questions?
I'm always muted, which is fun. Does anyone have any questions? No, it's all. Oh, don't come over this way.
Hi, thank you for the talk. Is it for the tool you have to paste the password into it? Is not actually accessing the clipboard a choice, or did you just run into some roadblocks with it? Just directly access the password in the clipboard?
I mean, currently the tool, I wanted the tool to be very simple, like with zero functionality. So you can either type your password in the terminal yourself, but why would you need the tool? Or you can copy paste it in the terminal. So it doesn't access the clipboard itself. It just takes whatever it receives from the terminal. So it's similar to SSH login. It just doesn't show you the characters when you type it in, but other than that, it just receives the password from the standard input and tries to type it in, like you emulating keystrokes. Does that make sense?
Just a quick clarification. I'm assuming the dev input or send input do not depend on the type of keyboard you have.
This is an interesting, actually, question, and I think different operating systems have, even when I implemented the tool, like the API is a bit different. So for example, on Linux, dev input actually emulates keys on a keyboard, so you operate in key codes, right? Whereas on Windows, the send input function actually, you hand it like Unicode characters. So yeah, different operating systems have different.
It will break if it is a US keyboard or a UK keyboard kind of situation. That's what I was trying to get at. Does it work with different keyboards, or will it break if I use a US keyboard or a UK keyboard?
So I'm not sure, to be honest, on which operating system you use and how it is configured. I would technically not advise to use like ASCII characters or symbols for passwords, because it can break many web applications, right? It's better just to have like a longer password.
The only point is like the @ symbol on UK and US are at different places. That's which is quite a common input character for a password.
Yeah.
So that's what was like, will it break that? To be honest, that's it.
I encourage you to test it and submit a GitHub issue if you want, or even a pull request if it doesn't work.
That is a quintessential screw around and find out. Anybody else have any questions? Sorry, you appeared out of nowhere.
Have you had any issues with like stuff like antivirus, like saying, hey, there's a random process sending keystrokes?
Do people still run antiviruses these days?
Ooh, harsh.
I mean,
yes, no, maybe, sort of, possibly.
No, I don't run an antivirus.
Fair enough.
Just a question to find out what your personal preference is. If you go back to the beginning of your display, you're on about brute force attacks and dictionary attacks. So if you're using a password, let's say, in excess of 25 characters, most people, as you say, can't remember that. So the thing is, a lot of them write it down on Post-its or in books or something like that, which if you find a book, you get a book full of kind of passwords. So when it comes to, you've got to renew your password every month, 3 months or whatever, is your preference towards not having that renewed quite so often, so people will actually remember that password, because otherwise they'll get a bit hacked off if they're trying to get big password done in every month, or are you more inclined to still say that the password should be changed as often as possible?
I think I would follow the Bruce Schneier's, post on renewal passwords. That it's actually, he presents an idea that it's harmful in terms of, like, if you force people to password rotation, to rotate passwords, they actually start coming up with insecure passwords. And I think I noticed myself doing this as well on like dodgy websites which require you to do so. Of course, the ultimate recommendation is still use a password manager. If you have to renew your password, you just go and click button, generate a new one, and you will always get a random password. It will not be tracked by like password tracking history a web application may to implement, and just put it in. So yeah, and password managers usually don't require you to rotate passwords as far as I know. So like your master password, come up with one big secure password, remember it, and like stay with it forever. But don't write it down in a book.
I have all mine in Post-it notes. Ladies and gentlemen, give a big round of applause to Ingvar.
Thank you.